Hi, my name's Murray Morrison. I'm the founder of Tassomai, and this video is as a pre-record of a webinar we're about to deliver this afternoon to teachers talking about Tassomai's data and how to use that to support good usage in your school and to meet various needs you might have for assessment data. This evening's presentation clashes with a lot of schools' parents' evenings, so hence us doing this pre-record. Hopefully this is giving you the information you need. If you need to get in touch with me at any time, and obviously you can't do the Q&A bit, murray@tassomai.com. If you can spell both those words, then we can talk. So I'm going to get my face out of the way and we'll make a start on the presentation. Hopefully, if I put my face there, I'm not in the way too much. Right, so quick overview. Background and housekeeping we've sort of done there. What we're going to be mostly focusing on is the data in Tassomai, but first I'll give an overview of the product generally for those of you who are not familiar with it, new to the program, or even considering using it in the future. Obviously there's loads more information on every bit we're going to touch on here. I'm going to try and be as whistle-stop as we can. We've got a lot to cover. So we'll look at the program, we'll look particularly about the data and how you can use it to support your students' learning, to plan your teaching and intervention, or to justify teacher-assessed grades and so forth. We'll look at some of the research and evidence that we hold on the program, and that's useful obviously for giving you confidence in using that to support your tags and so on. And then we'll come on to teacher-assessed grades and how you can extract the data you need and a few bits, tips and so on. So in a bit more detail, we'll give that overview of the program. We'll look at the attainment data and I'll try and dig into a bit of the maths behind it and look at the evidence, and then we'll do a bit of a practical demo on teacher assessed grades, hopefully, how to get it and a few caveats. So, and then there won't be a Q&A because this is a pre-recorded video, but as I say, by all means email me or email admin@Tassomai and it'll find me. So first of all, an overview. What students do on the platform. This is really for newbies to the program, how it works for students, and then how to see that data reflected to the students themselves, to parents, to teachers, and supporting implementation. So we will move this way. Here we go. This is a student account. This is my account. So this is what students see. They will have a daily goal to accumulate points through accurate answering of questions, and they're trying to fill in that green wheel. So I've done my English, I have science and maths to do. I'm not going to make you sit through a whole quiz, but I want to start a quiz so you can see what happens. So this whizzes by quite quickly because students don't want to look at it too much, but I think it's important, and it's important to explain to you what we're doing. In this quiz on geometry, I'm quite good at this topic, apparently, and so it's giving me very extended quiz intervals. It's only asking me this topic occasionally, and the focus is more about covering the content and stretching me. So this is a strong topic for me. Weaker topics have a higher frequency and more focus on correction or scaffolding questions. And then in the breakdown, you can see most of this is about confirming questions I've got right, I can still get right, maybe correcting a few mistakes and a couple of new ones. But the breakdown of questions is really tailored to the student on a per topic basis. So the idea is that they are getting targeted practice in the areas of most need. This is all important background for stuff we'll come on to later, but I'm going to get out of this quiz really, but you can imagine how that works, and correct answers accumulate points, and I need to get 38 points to be done for the day. So it's all about building a routine of regular practice and having that practice targeted for the student's need. That's not what we're doing today, but I am talking about data. So what data do we show the students? Well, aside from all this sort of thing where we can see how many points I've got each day and whether I've met my targets, and I can break that down by subject, all that kind of stuff. The exciting data, I think, is what we show them in the tree. This, I think, is going to come up with physics first. So here's my physics tree. It's a map of the curriculum for me as a student. This is this is edXL physics, and it shows the branches of topics. So this is electricity. This is a weaker branch where I have more yellow and orange leaves. So that topic is radioactivity. And you can see as a student, I've got a weak branch, or I've got mistakes on the tree, these yellow and orange questions, and I can dig in and see what that question was, what the right answer was, and so hopefully direct a little bit of my own thinking or revision myself. We're about to launch a link in that takes you straight to bite-sized articles on this as well. So students have this data to explore. I'm really struggling on this particular topic of the atomic model, and up here classic transformers and the national grid. I'm making a few mistakes there. So that's data we give to students to hopefully explore their own knowledge. That's quite a big tree, by the way. If I look at something that I've done less of, like Macbeth, you can see that's a sort of smaller, less developed tree, and so forth. So the tree grows as their knowledge grows, and the data reflects where their strengths and weaknesses are and lets students kind of dig into their knowledge gaps. So that's what we give students. If we move on to what we give parents very quickly, they get a weekly progress report, provided you've got parents set up on the platform, which tells them a little bit of a summary without going into too much detail, how many days their child's been active on the program and their accuracy. And that's an important stat, because we'll get on to how you can kind of get the right message out to parents. But accuracy 73% is kind of decent. Much below that is a reason to kind of have a little bit of intervention there. It tells you your best and worst topic. You can see I've basically guessed in that topic on unseen poetry by the looks of it. 24%, that's not good. And it gives parents access to log into their own account, explore the tree for their son or daughter, and have a look at that data themselves. It also lets them set up one-to-one free private tuition sessions with me. Here I've been explaining Newton's second law by the looks of it on the blackboard. That must have been yesterday, already forgotten. So that is really, really useful, I think, and valuable to parents. You need to just talk to us about getting parent reports set up if you haven't already done that, because it's something you need to opt in for, but hopefully you can see the value of that communication with parents and sharing of data. Moving on, this is the teacher view. So this is me looking at the moment at one of my trilogy classes, and I can see a couple of things here. First of all, these tiles just tell me who's been doing their daily goals. So this is the kind of policing side of it. I set it as a homework. I ask my students to do a certain number of daily goals per week. 4 or 5 I think is good to aim for, because we want to build that routine. And this tells me who's done it. So I click on this, I'll get a list of who's done what, and so forth. And you can see here which 3 of my students haven't done any, so I can have a word with them. They're the ones who've not done any. So fine. That's all well and good, and of course you can use that to drive usage, and we'll give you a bit more detail on that in a minute. But more exciting for me is what you can see when you click on the understanding grid, which tells me for this class how my students are actually getting on in the subject. So this is science, and I've got some students who've not done much, of course, with very small dots, but I'm interested in looking at how they're getting on in, for example, biology. It just gives me a breakdown of their attainment. Now, there's lots more information on what these things mean, but very briefly, the colours of the dot indicate stronger or weaker topics, where blue is great, green is okay, orange not so good, red really an issue. So you can see my whole class struggling, unsurprisingly, in quantitative chemistry here, lots of red dots. And you can even get a further breakdown if we break down bonding structure. You can see a lot more detail. The size of the dots tells you how much of the content they've seen. So if you see very small dots, that's an indication that students are missing chunks of, or they just haven't done very much yet. So the dots grow in significance as they cover more of the course. All of that's going to play into what we get into later. So you can explore that data. You can even pick up on what questions a particular student's been getting wrong and see the detail of their answers. So you can really explore that if you've got the time to do it, especially if you have a chance for some one-to-one work. So very briefly, that's the sort of data we show to teachers: how much they've done, whether they've done what you've asked, and how well they're doing in topics. We also give you this in data drops, which we have here. One shows the extent to which classes are engaged in doing their daily goals. So you can pick up classes that are doing really, really well. So 11P4 in English, everyone's doing their homework on Tassomai, great. 11Q1, 11Q2, great. And then you can pick up on some classes which aren't doing it. This is important for something, again, we'll come on to later for tags, to be aware of where classes are more or less engaged. This is a free feature we give you in a Google Drive sheet. More information on that in your Teacher Hub. If you're not sure how to get there, I'll go there in a second. We also give another live spreadsheet which tells you week to week who's done their daily goals. This is my maths class 11P1. Don't worry, these are all made up names, the random name generator that I use to populate the spreadsheet, but it tells you who in my class hasn't done their daily goals and so on and so forth. So this data is there for you live, and this is where we get into good stuff for supporting implementation. You can have leaderboards on who's done the most questions correct, or most days active, or spent the most time, all really nice for internal within the class prizes and competition. You can also have competition between classes. I'm racing through this because there's lots to cover. You can have this kind of milestone stages, so whether as they pass each milestone you could perhaps do post-class home and that sort of thing. And my favourite bit of this is the raffle, where everyone who's done, for example, an active day has a ticket in the raffle, so they can have up to 7 tickets, and then you can draw the winner. And just occasionally, all right, somebody with 7, great, they're going to be more likely to win the raffle, but you can occasionally get winners who haven't done quite so much. Well, Jared won twice. There you are. Brady, with only 3 days active, wins a prize. So you don't always get the same usual suspects winning prizes, and you can do this in a year group assembly on active days and so on. More detail on that in a separate presentation, which you can find on the Teacher Hub. I'll show you where that is now. If I go back to the Teacher account, on your sidebar, scroll to the bottom, Teacher Hub has loads and loads of cool stuff in here to support implementation. There's the link to the webinars on data drops, but there's also... No, thank you. There's also how to get in touch with Min or Chris, and lots of resources and videos on here, so please take a look at them. Right, now back to my presentation. I think that's a very quick overview of what Tassomai is and does. 10 minutes in, okay. Now we're going to talk about the actual data. So what data do we hold in terms of student attainment and its ability to predict outcomes? That's what we're really talking about. Whether you're going to use that to plan your scheme of work, to plan a sort of targeted intervention for groups of students, or the big question of supporting or evidencing your teacher-assessed grades and the drawbacks of that. So, right, what data does Tassomai hold? And so on, and what does it mean, and what are we calculating? Okay, I'm not sure what I've got here on the slide. Great, okay, so first we're going to talk about progress. This was a big mistake for me to call it progress, when obviously that's a word we use as teachers to mean something different. So internally we sort of slightly jokingly call it Tassogress. Most sensible thing to call it is Tassomai course completion. But on your teacher view, well, skip. On your teacher view of a class, you'll notice for students here, if I just view one student, again, not real names, so nothing being betrayed here. You can see here we talk about total progress, how much of the course this student's done, 70%. So what we're talking about here is how much of the course they've covered, and we'll go into the maths of that in a bit more detail. And because of the rate of progress and how much he's actually doing and how soon the end of the course is, we can also predict how far they're going to get come. I think we've set the end as early June, late June, because obviously there are no exams this year. So we talk about progress. When we talk about progress, we're talking about Tassomai's course completion. So, right, we'll get into the maths of that in a second. We also have those dots, which give you a very good indicator of how well somebody understands a subject or a topic within that subject. So it's a graphical view of very similar information, where this time we're splitting apart how much of the course they've seen and how well they're doing in that course. So we're going to just talk a little bit about how we work those things out and what the difference is between them, which is the next slide. So, Tassomai course completion. All right, so within a set of content, and that set could be anything. It could be a tiny topic, or it could be the whole of biology, or the whole of science, or the whole of maths, whatever. Within any set of content, we have questions. And that set of questions, each one is worth 1 point. Okay? Now we give a value to each student's last 3 answers, and that value adds up to 1 point. Okay, so each of the last 3 answers is worth a fraction of a point. Let's say it's a third, a third, a third. Well, if you get it right 3 times in a row, you get the full point. If you have it right, wrong, right, you have 2/3 of a point. Now, we don't actually score at a third. We weight more recent answers more heavily than less recent answers. And there's a reason for that, which is indicated by the asterisk. We add up your score on your last 3 answers for each question, and then we divide by how big that set of content is, whether it's the topic or the course. So we can then say, you are this far through to the target of getting 100% of the content covered. We don't expect students to get 100% of the content covered, because that would mean answering every single question in the course correctly 3 times in a row. That's a big task. It does happen, but it's by no means necessary, certainly not to guarantee or to be assured of a good performance in an assessment, or just a good understanding of material on which you can continue progressing academically. So we don't expect 100% completion, but that's what 100% completion would be, is getting every question right 3 times in a row. Now, the other thing, and it's part of the reason I showed you those sliders on the students' quiz, is that when you do well in a topic and you are making good progress, that unlocks certain things. Those sliders change. We might say, okay, we're going to increase the spacing coefficient of this quiz and give it to you less frequently because you're basically cruising in this one. And doing that allows us to focus with more frequency on things where you're struggling. So relatively speaking, we can weight topics against each other and give more frequency on areas of weakness, which I'd hope you agree is sensible. But it also locks or unlocks access to new content. So when you're struggling in a topic, we reduce your access to new questions, and we make most of the quiz about correcting your mistakes or confirming your corrections. So, all right, you said 2 + 2 is 3. We ask you again, you say 2 + 2 is 4. Now we're going to ask you again to make sure you weren't guessing last time, and this is sticking in. And with each time, increasing spacing on that repetition. All the things you hope it was going to do, it does, hopefully. And so doing well unlocks access to new content. Doing less well prevents access to new content. All of that means that when you're struggling, you're in a topic, your ability to make progress in that topic attenuates. That is for a good reason. And this all ties together now. Why do we bias for recency? Why do we attenuate progress for students who are struggling, apart from the obvious? We are scoring them on how they're doing. Well, it means that topics where you are making less progress or you are struggling, or where you've recently made more errors, get weighted such that they come up with more frequency. So I hope that makes sense into terms of like why we calculate it the way we do. We scoring your last 3 answers on the questions you've seen. We are weighting your more recent answers more heavily, and we come out with a score. And if you're struggling, we don't let you progress so easily in that topic, so that we can bring it up more often and get you to kind of focus more on that area. So that is our progress score that we can give per subject, or internally at least we do per topic and so forth. The other scoring is what we reflect in the dots grid. And spoiler alert, it's very, very similar to the Tassomai with a subtle difference. Again, the dot, or that column of dots, as you'd see in the teacher grid, represents a set of questions. It might be ionic bonding, or geometry, or Pythagoras theory. It could be of any size or scope, and that column of dots represents that set of questions. We look at students' score in the last 3 questions they've seen. We have no recency bias, and we give a value. And that is it. That value then colours the dot in. We'll come on to that in a second. We also look at how many questions you've unlocked, and that determines the size of the dot. So when you've seen all the questions in the set, the dot is full size. If you've seen some of them, it's less than full size. Hopefully that sort of makes sense. I was going to talk about how the dot grows, whether it's a function of area or radius. I think it's radius. I can't really remember now. And probably not that interested in the internal geometry of our dots grid. Okay, so the dots grow as you see more. We score you in the terms of the accuracy on what you've seen alone. So there's a distinction. Your Tassomai is the points you scored out of all the questions available. So you could do the first question, get it right. Not that you could do it 3 times in a row without seeing anything else, but let's say you did one question, you got it right 3 times in a row, and you never saw anything else. Your Tassomai would be like tiny. You'd have got one question, 1 point out of maybe 100 available. You'd get 1% Tassomai. Your dot score would be bright blue, 100% accuracy, but the dot would be tiny. So that's a way of unpicking very similar information. So yeah, the 4 colours represent bands. I think blue is from 100% down to 85%. Green is, I think, 85% down to 70% or 65%. I should know this. I don't. If you hover over the dots, it will tell you and you'll soon figure it out. Orange is then 65% down to 50% and red is below 50%. Why so high? I don't hear you ask. That's because every time you make a mistake, you're going to see more of that content in, hopefully with supporting material, a more supportive way. We expect students will, if they're making an effort to do well, will score from 65 to 90% accuracy. That's the sort of range of distribution of accuracy. Even students of low ability should be scoring 65% and can quite comfortably score 75% if they take a moment to just sort of look back at their mistakes and learn from them if they're minded to. So we set that band. Don't forget, Tassomai repeats itself, as do I, quite a lot. And so 50% means somebody's not trying very hard, basically. Right, so that is, that's the 2 ways of calculating. The distinction between them in the end is academic. We've looked at data analyses of these 2 different scores for schools' sets of data and done, Spearman rank correlation coefficient between them, and it's been 0.99. The distinction is almost non-existent. This recency bias really doesn't change things that much. And that's going to be important when we look at now extracting this data for teacher-assessed grades and so on. We're going to move on now, apologetically briefly, to evidence of data. I'm going to look at it quickly so you can be assured that this is out there. You can contact me for more. Where do I go to this? I think I go left. Okay, so we have this data report. Actually, I'm going to go right a second. Go to our website on the home page, and you'll see up here impact. And if you look here, you will see lots of information if you scroll down, which I'm about to show you. But you can also download this impact report where we try to summarize quite a lot of evidence work and research work we've done. So download that report, take a look at it. I'm going to just show you a couple of pages from it as a very quick overview. The main message is we have lots of information we can kind of supply you with, and if you get in touch, we can talk you through lots more detail, ins and outs of this. Essentially, before the GCSE reform, did a massive study, and before GDPR made it hard for schools to share data, we did a massive study with schools where they sent us all their module grades and we correlated that with usage. So we're talking about nearly 70,000 independent school marked assessments, or nationally marked assessments, actual GCSE results. We correlated that with the students' usage specifically in that module on Tassomai. So we could do a pretty fine-grained analysis, and then we got this kind of ranking. Now, what this basically means is, although it's missing a key, it says up here, these strong passes in the old system, A, B, and C, are blue to yellow. So you can see as usage increases, there's a much higher proportion of high outcomes. Now, we'll get into the correlation causation as a separate issue, but when you're looking at predicting attainment or predicting grades or planning intervention, you can be quite confident that those students who are making really good progress on Tassomai are ones who are going to do quite well in that topic. Whether Tassomai is responsible, as we'd like to believe, and we can show you other studies into that, or whether they're hardworking, very able students, and so they make progress. The two things both have aspects of truth about them, of course, but in terms of what you want to get that data out, you can have pretty good confidence that high progress is going to map quite strongly onto high attainment. This is where this came from. This is a whiz through, but we can break this down a little bit more. So course coverage, extremely low. If you just look at your sort of blue to yellow section, these are your strong passes. Extremely low breakdown, extremely low course coverage. There was a low high pass rate, 26%. And as we skim through increasing usage, you can see how that increases. So this is the area where we want to focus on. As students get sort of to 20, 25% progress on Tassomai, you tend to start getting a very much stronger rate of high passes, and we'll look in a bit more detail at that in a second. And then as usage goes up, as you'd hope to expect if you're investing in an EdTech program, the kind of attainment really goes up. And that's the sort of breakdown in a little bit more detail of that bar chart, stack bar graph. A bit more detail on this. So this as you know, is pre-reform. A started to C. Then GDPR happened, so schools were much less able to share bulk data, or it was much harder for us to get it. But we were very keen to kind of pick apart some of these questions of correlation and causation. So this is an independent study by a school that looked at Tassomai usage against the prediction they had for those students. They're using the FFT 20 standard for prediction, and what you can see hopefully is once students pass about 20-25%, there's an extremely high correlation between good usage and meeting or exceeding predictions. So that's a really important takeaway. Below that level, well, in this case actually it really does look like those low using students tended to meet or not quite meet their predicted grade. This is a FFT 20 is quite a high standard, as you would know, for predictions. A separate school, separate study, and this is a very classic kind of pattern, showed that students with low usage, anything can happen. It doesn't really indicate much. If they've not used Tassomai, they might be very able students who just aren't doing that homework. But students who did use it then tended to get very nice progress scores in excess of the sort of school's average, which I think was around 0.68, if I remember the email. It was a couple of years ago now, and that increased. Now, it's all very noisy, lots of confounding factors, but the main takeaway, again, is once you're past about 20% progress, you can be pretty sure that students who've done more than that are very likely to do well, very unlikely to disappoint in terms of their grades. Below that level, could mean anything. So that's what we're kind of getting at, just in a little bit more detail on that. Right, where are we? Oh, I had a slide here. There we go. So CR impact report, I've shown you how to do that. Looked at some historic usage to attainment data. The question of correlation we were very keen to do, so we did an independent pre and post study where we looked at students' attainment on Tassomai, difficult recall questions at the beginning of their time, at the end of their time, correlated that with how much they actually used the program, and produced this graph, which is, somewhere in here. There it is. And we separated that, we stratified the students by their initial attainment being higher or lower, I think above or below median, and showed the change in recall. Now again, you can pick this apart. It's very hard for us to say absolutely without doubt, but this was randomized, this was across the country, no context bias and so forth, and we saw certainly a really nice increase in attainment for heavier users based on their initial attainment. This axis here won't mean much to you, but it pretty much maps to progress. So we're probably talking about 20, 40, 60, 80% Tassomai course progress. Just hopefully to give you some basis of confidence that even lower attaining students, when they did Tassomai a lot, you've got some justification to say, yeah, they would be likely to achieve better than expected in the exam. Not that there's an exam. Right, so that's that bit, and then a little bit more granular. So we were very interested and very keen to check out how our DOTS data was performing in terms of predicting outcomes topic by topic. So we did a big study in the collaboration with about half a dozen schools around the country, where we got their agreement to share mock data results from the mock exams in November, in March, and I think also the final exams in the summer. So we got several data points. I think the two mocks, because we couldn't get the detail on the final exams. We got the two mocks. We had 6 papers per student. We had thousands of students. We had a lot of fun going through all that data. We correlated we looked at the mark scheme of the paper, we looked at the mark they got, we correlated how they did on that mark, what topic or subtopic it was assessing, and we looked at the DOT that student had at the time, and we tried to measure how well that dot predicted their outcome. Obviously, huge study with tons of noise in it, but when we kind of de-noised it a bit and looked at the trend, this was the shape we saw. So this is raw mark outcomes versus dots, and this basically says when you've got teeny tiny dots, this is worth noting, we'll come on to that when we get to the caveats, when you've got teeny tiny dots, it means very little, very noisy. They could have done one question, got it wrong, got a tiny red dot. They do brilliantly. Or you could have a tiny blue dot and it will still rank extremely low. So we'll look at dot ranking in a minute. When you've got tiny dots, you can't read anything into it. But once dots become a little bit more chunky and you've got more confidence in the size of the data they're looking at, then these dot rankings, and I'll show you how to rank the dots, become quite good predictors of exam mark outcomes. Again, this is in the data report and there's more detail on our blogs and things. But that's, again, I think gives me quite a lot of confidence in that what we're showing you in terms of dots actually means something. And you'll notice again this nice chunk up here. Once you get into green and blue dots, you can be pretty confident that these students are scoring 60, 70, 80% in that exam, which is a good indicator of a high score. Right, so I'm not going to pretend that's more than it is, but I hope that's enough to say, as assessment data goes, it's pretty robust. Right, now we get into the home stretch, which is teacher assessed grades. Good luck to you all in your teacher assessed grades for all these students. I don't envy you at all, but I do want to be there to support you if you need it. Please get in touch with me if you want to kind of have some one-to-one time and look through things together. The main takeaway is, if you don't have much data in Tassomai, you don't have much data to support your tags, because at the low end of usage, it's extremely noisy. There's not been the opportunity to really pull those students apart and be able to give them a meaningful ranking. But if you've implemented Tassomai well, then we can get into the data better. I don't feel like I really gave you much on supporting good implementation. Sideline, I'm just going to mention that again. The main thing to do is to get your students to do their daily goals every day. The clue's in the name. And to use your data drops or your dashboard to find those students who aren't engaging and give them the nudges early on to get them into the habit. Habit is so powerful, as of course you know, and really key to getting the program working well for them and getting them learning well from the program. So do your daily goal every day. Message 2 is, we expect accuracy of 75%, which is a big call, but it's an aspirational call. It is important. If they're answering as well as they can and avoiding avoidable mistakes, the program will give them what they need and help them focus on areas where they're struggling, and it'll be more able to find out where the gaps are. If you let them get away with kind of guessing and being a bit throwaway about the things they're not sure about, then the program won't perform so well for them and they'll get less out of it. But your data will be less useful too. So do it every day, accuracy 75% as an aim. And then use your data drops or your dashboard to monitor that very accurately and build some nice routines, pastoral and less pastoral, around that. Okay, so how to get the data and process it. On your teacher dashboard, you have loads of this data. That's where am I going to put myself? Put myself there. So that wasn't very good. You have lots of data. Well, at the moment, we're looking at an individual student. Let's look at a class. You can extract from here their data in terms of their Tassomai progress, their Tassagress. So clicking on, I think, any of these tasks, but daily goals will show you everyone in the class, and it will show you that actually this is showing you what they've done today. I should have practiced this. I should know my way around the site. There we are. Okay, if you click on the progress tile, that would have been a good place to start. It shows you, okay, what people have done today and how much progress they've gained today, but it will also show you their total progress. Now, our data is a mess because we've got a bunch of people doing quizzes to just populate it, and we will start and finish at the same time. In your classes, you'll probably find much more cohesive data, but you can show these students in your class or in the whole year group. You can click on year 11 and get the same data. It'll be I'm not going to do it because we've got a mess of all sorts of stuff in here for the purpose of demonstration. But if you look at your whole year group, there you go, you're going to have the whole thing. But you can then rank students by their total progress. At this point in the year, total progress and predicted final progress is going to be very similar. As you can see, quite a kind of close mapping because we're near the end of the year. Early on, that predicted final progress will give some degree of projection based on their kind of rate that week, so it's a little bit volatile. Look at that total progress score, you can rank them, you can download that into an Excel file, and that's that. I don't think this is actually the best place to go for it though. Personally, I would recommend you, if you have your leaderboards, you go there, and in your class outputs, you can, for the subject of your choice, instead of choosing a class, you can say all students, and you've got your whole year 11. Make sure you're not penalising people with low accuracy this week. That's really important because they're excluded from the leaderboard if they've been spamming and guessing or not doing enough. So untick that box, and then you will have your whole year 11 in your leaderboard, or your year 10 or whatever. And then you can select from here, rank them by total progress, and there you are. Again, no worries, these are made up names of students, but here we've got our list of students all the way down from who's done most to who's done least. So there you can extract that, copy it into your spreadsheet as you like. So either from your dashboard or from the leaderboard, that's how you can get that. The alternative is to rank them by their understanding dots, which I think has some advantages. Again, apologies, this is slightly patchy data with some sort of odd students in here that have used more or less. In your class, you'll see something a bit more cohesive. For science, where we are at the moment, again, you can rank them overall by clicking this down arrow, and it just shows you that same thing. And it correlates very closely to Tassomai progress. So the choice is yours, and there's not much difference. But this feels a little bit more. It's giving you more information visually, and you can also separate it by, in this case, biology, chemistry, physics. You see a little change in ranking there. So, and you could, if you really wanted to, even rank them by particular topics within biology that you think are kind of the most important ones. Now, this is where this all comes together now, is if you have this data and you want to use it to support your predictions, number one thing is, please don't extract this data and make this the source of your rankings. Not obviously that you were going to do that anyway, but I do need to say that. Because an able student who hasn't done Tassomai, if we give them a low score, that's not an indication that they wouldn't have done well on the exam. It just tells you they haven't used Tassomai much. What you can do is use this, if you start with your many other sources of data and your knowledge of your students to rank your students top to bottom, and you can then say, use the Tassomai data to say, actually this student who is traditionally of lower ability, lower prior attainment, whatever, they've done really good work and they're high up the rankings. We can be justified in giving them a better grade because the data shows it. They've worked really hard, they've shown they've got a good understanding. And it gives you the evidence to support giving those deserving students a little bit of a boost above where they might otherwise have sat on the bell curve. I would be much more cautious to do the converse and say this able student hasn't done much Tassomai, so they should get a worse grade. But in the wider context, if you know they've not been doing any work and they've not been doing any revision or practice, then that may be justification too, but I'd be a little bit more agnostic on that one. So hopefully I've shown you how to look at this data. The other big caveat I have is I've shown you ranking students within a class. You can do it by the whole year group. I'm not going to show you this because it's going to look a mess because I'm looking at lots of subjects with one teacher. But if you look at your year 11, you'll see a nice whole ranking of its classes. Now you can do that for this DOTS ranking or for their Tassomai progress ranking, as I've shown you. But you do need to be conscious of different use cases in different classes. So I'll show you what I mean over here. So here, if I let's say we're just looking at maths. If I filter this by maths only, you'll see, and I'm just going to show year 11, or you can see top few rows of year 11. You'll see that some classes here are consistently highly engaged, right? This 11P1 is using Tassomai a lot, is what that means. Meanwhile, 11P2, that teacher, or 11P4, 11Q1, you see those classes, that teacher's not pushing it, not making it homework. That shouldn't be a reason for those students who will appear lower in the rankings to be penalised, or for their peers who are in high usage classes to be unequally promoted. So you do need to look at the rankings within the context of a class, or in conversation with those teachers, to make sure that the volume of usage, which may be an external influence from the teacher, doesn't force some people up or down the rankings unduly. So I'd be really careful of ranking the whole year group without then contextualizing by something like this. How much did this class use it? How much did this teacher promote it? But ranking students within a class, I think, is much more justified. So you can take my single year 11 trilogy class, I know that looks like a year group, doesn't it? And rank them, and I think that's a pretty good indication that Vihan and Henry were going to do better than Min and Natalie. Likewise with the understanding grid, you should probably see the same kind of rankings. Yeah, actually Chris has slightly leapfrogged Henry, there you go. So it's not always exactly the same. Doing better than Min or Natalie. That's all I would say on that. I've really kept you a long time. It's a 40-minute presentation. I'm just checking my notes. Oh, I should go to my presentation. There we go. Things to avoid and why. Hopefully I've done that. Avoid reading too much into small dots, and particularly because they can provide false negatives, and also avoid ranking whole year groups without considering how different classes may have used the program more or less, because usage is a big driver of those attainment dots or attainment scores. No Q&A, obviously, but the Q&A should be, drop me an email, murray@tassomai.com. I can happily make time in my calendar to have a conference with you, look at your data with you, tell you what I think, or give you a bit of a steer. If you've made it this far, thank you. Well done. Sorry, I'm a real rambler, but I hope that covered what you needed, and I will leave it there, and thank you very much for watching. Bye-bye.